Hello. Okay, yeah, sound is fine. Okay, so let us start. Okay, all right. So in the last stream, we have reached up to the data set, extracting data set. Okay, that part. So how we're going to do it? We're going to add gedit extract dataset.py. Okay, so here what we have done earlier, it was written fun v, should be function, na? So it will be c here. Okay, so it will be c, and another issue is here it will be 20 by 9, otherwise it will give us division by 0 error. All right, so these both were the errors which we were getting. Okay, so I will save it, go back, clear our uh, clear our terminal, and then run this script. Okay, python 3 extract dataset.py. So now it will start processing each and every case. Okay, so it is going to take much time to process. All right, so we don't have anything only to wait. Okay, if it doesn't give any error to us, then we will have our dataset generation. Okay, this is, I think, the longest dataset generation we are doing it. Okay, because we have many cases, so it is going to take time. Hey, how are you, Jay? I am good, man. I am good. How are you? Is everything fine there? How's your health? So, what we are doing? We have run the different cases, all those cases we are having. Now from those cases we are extracting our data sets. Okay, so there were number of time steps in each and every case. So how many cases we are having? Let us check. So let's go to cd pits ai, let's go to cases. Okay, so here inside case 0 it was, sorry, 0, it was this much number of cases we are having, 848. Okay, we have to wait a very long time, right? AI ऑप्टिमाइजेशन कैसे करते हैं, थोड़ा ब्रीफ दे दो. अरे यार, एरर दे दिया. ट्रेस बैक. पहले ये बता तबीयत कैसी है और पानी का सिस्टम क्या हुआ, कुछ सही हुआ वहां पे? तो ये लंबा टाइम लेगा आज सॉल्व होने के लिए. किस चीज के लिए एआई ऑप्टिमाइजेशन करना है पहले तो ये बता ना। हार्ड क्वेश्चन। मतलब नहीं सही हुई। अरे न्यूज में आ गया था भाई, सब टैंकर से पानी भर रहे थे यार। अरे मतलब रिजल्ट्स आ गए, डेटा सेट जनरेट हो गया। नाउ मूविंग टू एमएल पार्ट। हाँ जय। फिर जी एडिट एक्सट्रैक्ट डेटा सेट। पहले सीएफडी तो उसकी रन करो, सीएफडी रन करने के बाद फिर कोड से वो, फिर पहले डेटा सेट निकालेगा तब ऑप्टिमाइजेशन चालू होती है ना। अरे यार व्हाट एरर्स आई हैव डन। अरे आज लंबी जाएगी, मन करे तो सो जाना कल। कल देख, कल बात करेंगे। ये डेटा सेट जनरेशन टाइम लेगा अभी है। करते हैं, अच्छा टाइम मिलेगा तो मैं मैसेज करूंगा एक बार, देखते हैं फिर। और डिनर विनर हो गया भाई? बारिश हो रही है कि धूप निकल आई? अभी गर्मी है वहां पे? अच्छा। अरे यार एंड के, so let us check our data directory. Okay, we have our data directory, all right. Clear nano data set.csv. हाँ, okay, only this much. Okay, I was thinking that it will give us a very long data set, but it has given us this much only. Okay, 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 bhai, okay. Okay, so now let's go on writing the script for AI model. Okay, so train model dot py, right? Okay, so first will be import torch, import torch dot nn as nn, import pandas as pd, df is equal to pd dot read csv. Now we have to give the path. Okay, cd, go back, cd data pwd, control c. Okay, all right, let us write it. Paste dataset dataset.csv. Okay, x is equal to torch dot tensor df step height dot values, d type is equal to torch dot float 32 dot view -1 comma 1. Okay, same we are going to write y. Hmm. साला CFD कौन भाई कौन? कुछ भी भाई, कुछ भी। Model is equal to nn dot sequential nn dot linear 1 comma 32 nn dot comma nn dot linear 32 comma 32 nn dot linear 32 comma 1. Optimizer. By the way, thank you for that one. I like that. Okay, अच्छा लगा सुन के, थैंक यू। पति 0.01 loss fn is equal to nn dot mse loss, all right, for epoch in range 1000 predict is equal to model x loss is equal to loss function predict comma y. Optimizer dot 0 grad loss dot backward optimizer dot step if epoch percent 100 is equal to 0 print epoch loss torch dot save model dot state dictionary comma where we wanted to save. Okay, so we wanted to save our model here only. Only we will change it to model dot pt. Okay, save, cut. All right, clear. Python 3 train model. Why there is no loss? Data set is something which I am not, this 1.74 to the power of 10 raised power of 63. That is concerning, right? Which means when the geometry has changed, some meshes have become unstable, solver has diverged, pressure becomes astronomical. That's why it is coming like 1.74, because what we are changing the geometry. So when we have changed, the mesh has definitely become distorted. Okay, so we have to filter this. Alright, we will remove these bad cases from our training. Okay, alright, so let us go back. Okay, let us go to data, remove this model, go back, go to scripts, and again go inside train model.py. Okay, to here it is fine. Okay, so what we have to make the changes after this. So first we will remove the bad data. So is equal to df in np dot absolute df pressure drop 100. Okay, then print filtered dataset, print df. Okay, all right, then we will sort our uh, values. So sort df dot sort values step height okay, then we will not do a normalization. So it will be x is equal to df step height values dot values. Okay, y is equal to same thing, pressure drop dot values. Okay, then x mean is equal to x dot mean. Okay, then x standard is equal to x dot std. Okay, then similarly for y we are going to do it. So we will copy both of this and paste it here. Okay, so y y y. All right, Then we will do x is equal to x minus x mean divided by x standard. Similarly for y we are going to do it. Y is equal to y mean y standard. Okay, so then we will convert it to tensor. So that is what we were doing. So here remove this x d type is equal to torch dot float 32 view minus 1 comma 1. Okay, uh, mm, 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 mm. Okay, similarly we are going to do it here also. Y. Okay, all right, then our model, okay, that is same. Then optimizer, loss, epoch. Okay, we have done the training one also, and then we will print new line, training complete. Okay, save. Clear. All right, now let us run this train model. अरे यार, why I am doing this small mistake, huh? Using np and not importing numpy. Import numpy as np. Shit. Okay, see, it has removed that filtered one. Okay, and now you can see that loss is coming fine also. All right. Okay, so our training is also completed. All right. So now we will optimize. Okay, Now we will optimize our model. Okay, so we will gedit optimize.py. Okay, import torch, import numpy as np. Okay, so model is equal to torch.nn dot sequential torch.nn dot linear 1 comma 32 comma torch.nn dot lu comma, then we will copy this, copy paste, copy paste. Model dot load state dict torch dot load. We again have to load it, right? Let us save it and close it, because pwd ls, copy this, gedit paste data slash model dot pt, model dot evaluate this. Okay, is equal to np dot linspace 10 comma 30 comma 200. Best is equal to none. Best is equal to float. For p in predict is equal to model torch dot tensor p, d type is equal to torch dot float 32 dot item. If predict is equal to best value, best value is equal to predict, best parameter is equal to p. Okay, then we will print optimal step height, best parameter, and again we will copy this and print it, predicted pressure drop, best value. Save it. Clear. ls clear. Let us run this optimization one. So python 3 optimize.py. See, optimal step height is 10, and at 10 the predicted pressure drop is this one. Okay. Okay, so let us now make one validation. Okay, so let us now validate it. So it will be gedit validate.py, import os, import shuttle, import subprocess, import re. So we will go for base case, and yes, so here yes, so it will be base case, then we will go for valid case, and that will be, we will make one validation case. Okay, so for validation case we have to make one new directory. Okay, so we will make directory validation case. Okay, then we will go inside validation case, and we will write down the path and copy this. Okay, paste. All right, then we will go for best h. How much best one we have got? I think it was 10.5, right? Shit, again we have to run it. Pitzai scripts python 3 optimize.py 10. Okay, so that we have to write that. So best one is 10. Okay, then define modify case path h file path os.path dot join case path system block mesh deck. With open file path comma r as f content is equal to f dot read that will go inside it. Content is equal to re dot sub okay. Then we have to copy this, paste. I think everything is fine. R 0 s plus minus 25 4 s plus minus 0.5. Okay, okay. With open file path w as f dot write content define run if os dot path dot exists valid case shuttle dot rm tree valid case shuttle dot copy tree base case valid case modify valid case best h subprocess dot run block mesh cwd is equal to valid case shell true. Same for simple form. If name is equal to main run, alright, save, okay. Alright, so we will run this validate one, python 3 validate.py. Code dump, why this code dump is coming here? Array? Code dump? Mm, 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 mm. Core dump. Ah, yes. Yeah, it ran. So, okay. So, we have our validation case also. Alright. So, now we will make some plots. Okay. And with those plots, we will be able to get a clear picture of what we have done. Alright. So, let us make some plots. Okay. So, first plot will be this. Let me clear it. Okay. And gedit to say dataset plot dot py import pandas as pd import matplotlib lib dot pyplot splt df is equal to pd dot read csv. We will read our data set. So what is the path of a data set? Okay, inside that dataset.csv. Okay, again we will clear that data. So df is equal to df absolute df pressure drop 100. Okay, then we will sort it. Df dot sort values step height mm, and we will plot figure fig size 8 comma 5 plt dot scatter df step height mm df pressure drop, and we will plot. Okay, so we will copy this and only we have to change it to plot. And we will give some label plt dot x label step height mm plt dot y label pressure drop plt dot title cfd dataset plt dot grid plt dot show. Okay, save this one, clear ls. Okay, then let's run this one. Python 3 dataset plot. So it means up till here our code was right. No attribute as df. Okay, so for df we are not mm, 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 mm. Ah, small mistake I'm doing. Come on, man. Comma. Save. Clear. So this is our CFD dataset. So at 10, the pressure drop is -2. At 12.5, it has gone to this point. Then at this point, it has come here, and then it is going here. Okay. So let us save this. Where we can save? No. Okay. So we can give the name as plot create, and name we can give it as dataset plot. Okay. Save. Cut it. Clear. All right. Next plot we are going to make for AI versus CFD one. All right. So we will name it as comparison.py. All right. So import torch, import pandas as pd, import numpy as np, import matplotlib.pyplot as plt. Okay, again we will read it. Okay, then we will read our data set. Read csv. Okay, dataset.csv. Okay, then df is equal to df absolute df pressure drop hundred. Okay, df is equal to df dot sort values step height x real is equal to df step height values. Y real is equal to df pressure drop dot values. Okay, then x mean is equal to x real dot mean. Okay, x standard is equal to x real dot standard this. All right, y y y y. Okay, then x will be equal to x real minus x mean x standard. Okay, x tensor is equal to torch dot tensor x comma d type is equal to torch dot float 32 dot view minus 1 comma 1. Then model is equal to torch dot nn dot sequential torch dot nn dot linear 1 comma 32. Torch dot nn dot copy paste 32. 32 comma 1. Then model dot load state dict torch dot load. We will load our model. Okay, so it is in it only model dot pt. Model dot okay with torch dot no grad predict is equal to model x tensor dot numpy dot flatten predict is equal to predict y plus y mean plt dot figure fig size is equal to 8 comma 5. Plt dot scatter x real comma y real comma label is equal to CFD data. Plt dot plot x real comma predict comma label AI prediction. Okay, then we will label something x label step height y label pressure drop and the title will be AI versus CFD. Plt dot legend plt dot grid plt dot show. Save. Clear. Run this python 3 comparison.py. Let's see if we will get. The neural network has learned the physics trend from the CFD data. Ha 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 ha. It has followed the same thing. Am I right? Or am I right? Hmm. This spike basically, this is creating an issue. Okay, it has followed, but this one is yes, it should be negative pressure, right? Okay, in the data set, yes, we will go in the where we will go back. Okay, and if we go to our data, here we will find in dataset.csv. Yes, this one is also positive. Hmm. Let's go to scripts. Go to gedit train model.py 0. Save. Hmm. Why this error? Remove. Remove the model. Ah. Go back. Python 3. Hmm. 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 Empty data frame. Gedit train model.py. Yes. So now it has taken this part. Okay. Then we have ran the, I think optimize after that we ran, right? Uh, 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 Yes, we ran after this optimize. So gedit optimize. Okay. So then we can run it again. Python 3 optimize.py. Predicted pressure drop is 0.454. Okay. Then we have to go to validate. Remember this step height is 10. Then we will go to gedit validate.py. Yeah, it is 10. Okay. Yes. So clear. We will go back and we will again run this validation case, and we will have to remove these. Okay. Remove minus r 0 minus 9 0 to, I think the highest is 179. Is it? Okay, forget it. I'm deleting it from. अरे यार simple, what must I have done? I'm also a very fool man यार. Okay, so we have validated it. Okay, after validation we will go back and we will go to this dataset plot. So gedit dataset plot. Here also we are going to change it. Okay. Df. Okay, fine. Save. Clear. Then Python 3 was dataset plot. Mm, 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 mm. Why we are getting so many errors? Yeah. What we can do, we can go back, nano dataset. Okay. Remove this one. Alright. Control O, enter, Control X. Okay. Because okay. Then Python 3 train model.py. Okay, fine. For training we have optimized, right? So Python 3 optimize.py. Okay, then validation. Okay, validate. We will go back, remove this validation case, make directory validation case, clear it, again go to scripts, then run python 3 validate py. Okay, so we have done the validation also. Then we will go to dataset plot. So what we will do, we will go inside, we will run python 3 dataset plot. Yes, now it's fine. Okay, this one we can save. We'll go to plot and we'll save it as dataset plot 1. Save, close it, clear. Okay, all right, it is completed. Dataset. Vijay Sai, what's your V? What's your background? May I know about your qualification? I mean, why are you asking these questions, Vijay? Sorry, I was not seeing the this live chat. Do you have any type of job offer for me? That's why you are asking. Hmm? And what's your V? This V I didn't get. Vijay Sai 4934. Okay. So we have this data set plot, then we will go to comparison plot. So comparison, okay, this comparison, yeah, okay, that is fine. Save, cut it, clear. Then we can run this python 3. I can see how it is scattered. Okay, earlier it was following, but now it is scattered. Huh? No issues, we will fix it. I think Vijay Sai has gone. Sorry. We are using polynomial fit. Okay. Polyfit x comma y comma 3. Poly is equal to np dot poly 1d x smooth is equal to np dot linspace minimum x comma maximum x comma 200 minimum x. Okay. Hmm. Why Mr. Vijay? Yeah, was asking for my qualification. I wanted to know, is he having some job offer for me? This is the life of a CFD engineer. Dealing with errors. Now it is somewhat, okay, it is not exact, but it is somewhat, you know, following the trend of the AI prediction. Okay, so now we can say it's fine, because earlier it was coming like exact, and this one, yeah, I was happy, but for some time, but I should not be, because exact data, like, okay. So the CFD simulations provide discrete physics-based data points. The AI learns the overall relationship between geometry and performance. Once trained, the model predicts the optimum design region instantly. Okay, so this was done optimization, comparison. One more plot we have to make. That is the last plot, and after that our thing will be completed. The optimization curve. Okay, yes. So gedit optimize plot.py, import torch, import numpy snp, import matplotlib dot pyplot as plt, xmean is equal to 25, x standard is equal to 5, y mean is equal to -5, y standard is equal to 1. Then model is equal to torch dot nn dot sequential, torch dot nn dot linear 1 comma 32, torch dot nn dot relu lu. Okay, copy paste. Model dot load state dec torch dot load. Again we have to, load our model. Model dot evaluate, then real x is equal to np dot linspace 20 comma 30 comma 200, norm x is equal to real x minus x mean x standard. Predictions is equal to for x in norm x, inp is equal to torch dot tensor x comma d type is equal to torch dot float 32. Predict is equal to model inp dot item predict is equal to predict y standard plus y mean. Predictions dot append predict eight comma 5 plt dot plot real x predictions plt dot scatter real x best idx predictions best idx plt dot x label step height mm plt dot y label predicted pressure drop plt dot title AI optimization plt dot grid plt dot show. Let us see what we will get. I write a code and I did not get error. It cannot happen. Huh? Ma. So instead of running CFD hundreds of times, this AI model estimates the performance across the design space almost instantly. The minimum plot on this curve represents the geometry predicted to give the best performance. Okay. So let me conclude all our things which we have done. Let me save this. It will be pits plot. It will be optimize. Save. Okay. So let us quickly understand the complete workflow of what we actually did in both the streams, part 1 and part 2. We started with the classic OpenFOAM pitzDaily case, which is a backward facing step flow problem. The main idea was to see how changing the geometry, specifically the step height, affects the performance and the pressure drop. Normally, in the CFD optimization, engineers have to manually change the geometry, rerun simulations, extract results, compare designs, and repeat this process many times. That becomes computationally expensive and time consuming. So, in this both the streams, what we have done, instead of doing everything manually, we automated the workflow using Python and OpenFOAM. First, multiple CFD cases were automatically generated with different step heights. Then OpenFOAM solved all of those cases automatically. After that, we extracted engineering data from the simulations, specifically the pressure drop values. That gave us a CFD generated dataset. Then we used AI and machine learning techniques to learn the relationship between geometry and the performance. The CFD points represented actual physics-based simulations, while the AI model learned the overall trend from the data. Once the model understood the trend, we used it for optimization. Instead of running hundreds of simulations, the AI predicted the performance across the design space almost instantly and identified the optimum region. And this is the important part. We do not blindly trust AI in engineering. The optimized geometry should always be validated again using CFD simulation. So the real workflow comes. CFD generates data, AI learns the physics trend, AI accelerates optimization, CFD validates the final design. That is the future of engineering workflows, not AI replacing CFD, but AI accelerating physics based engineering design. And with that, we'll end today's live stream. This was honestly a really exciting stream because we combined OpenFOAM, automation, machine learning, optimization, and engineering validation all inside one workflow. In the first live stream, I was getting bored, but now I took 2 days break, 3 days break, and after that I came back and I ran that, and I was literally, I'm happy that I can able to show you this optimization process. Okay, and this is just the beginning. In future streams on CFD Simplified, we'll go even deeper into neural networks for CFD, surrogate modeling, and many other things. Okay, thank you everyone for joining the stream, asking questions, and staying till the end. If you enjoyed this kind of content, make sure to subscribe to CFD Simplified and share the stream with others interested in CFD and AI. See you all in the next stream. Keep learning, keep simulating, and keep building. I love you all. Thank you.